Audio check 1 2. Audio check 1 2. Hello everybody, and thank you for joining this evening. Today we are doing this Desmos workshop for teachers. Now the reason we're doing this is because I truly believe that Desmos is a really powerful tool for maths teachers. It's a really, really useful website and application to help maths teachers visualize the concepts that we're teaching in high school maths. So today what we'll do is we'll give you a quick introduction to the Desmos. We'll show you some of the things it can create. We'll show you some of the resources we made earlier and the resources that are available to you. And then, as we get further in, I'll try and show you how you can create your own resources for your own personal lessons in your own unique style. All the maths we're going to do today is a high school level algebra maths. We are not doing any coding. We are not doing any crazy equations. Everything we're typing in looks like the equations students would write on their tests. So I hope that makes it a bit more accessible and less scary for you to use in your own lessons. For those of you joining live, I'm really interested in knowing something about you. So please do comment below. Tell everybody else what country you're joining from, what school or curriculum you teach, the ages you teach, and just a little bit of introduction about yourself. But also things like, what is your favourite topic to teach in high school maths? And then throughout the presentation today, I'm also really interested in the collaborative aspect here, the idea that we're all maths teachers from around the world, and we can all share our ideas about how to support our students better. So do comment in the comments down below if you have any ideas of the questions you might ask your students during these visualizations. How would you encourage better class discussion in this? Okay, so without much further ado, let's get started. Okay, so I am Will McLaughlin. I am a maths teacher at the British International School of Abu Dhabi. My background is I'm a maths teacher from the UK. I've taught GCSE, A-level and IB mathematics. I've also taught a bit of physics in my past. And for all of those courses, I have used Desmos to help teach those courses. I've also taught a little bit of American SATs and American algebra courses, so I have some idea of what content comes up in there. And I know full well that there's a lot of graphs on there as well. If you have other curriculums that you're teaching at your school, please do share below. I am running advancemaths.com, so I am the creator of advancemaths.com. That is a website for revision, supporting maths teachers, students and parents with maths at school. If you have any questions today, as I say, comment down below, but also you can email me at any time on advancemaths@gmail.com. So today I'm going to talk to you about why Desmos, why I think it's the best application for what it does, some resources we made earlier, and then I'm going to go in and do some demonstrations of the kind of stuff I would do to create my own lesson plans. As I say, please do introduce yourself in the comments below, and also just as we're going through today, add some ideas about how you would encourage class discussion while you're doing this in class. What would you ask your students, or how would you get your students involved in this? Some of the activities today are interactive, so students could even come up and touch the touch screen, or they could have it on their own devices, and those kind of ideas will be really interesting to hear from you. So do comment as we go, please. Okay, so why Desmos? Well, I tried to sum it up with 5 words. Those are intuitive. I think Desmos is a really intuitive program. And the reason for that is it doesn't take any IT skills, it takes math skills. Everything I'm typing in today is algebraic maths using the common notation that we're used to. It's visual, it's really, really clear application with very clear graphics. It's interactive, so you can touch the screen if it's a touch screen, you can manipulate the objects on screen very easily, and it updates live, and you can really see how the maths relates to each other in a way that we just could not understand 20 years ago. It's fast, so it works on mobile, tablet, and computer in exactly the same way, same interface. And most of all, it's really satisfying. So call me a geek, but I find Desmos really, really satisfying to use. And some of the stuff, when I managed to create a resource that perfectly visualizes what I'm teaching in class, I just find that incredibly rewarding and satisfying. And my students love it as well. My students like to see this stuff, and there's a lot of light bulb moments where they really understand where I'm coming from when they see it live on screen. Now, Desmos is really good for graphing software, but it might not be the best for other purposes. So if you're interested in geometry, I would recommend GeoGebra, and if you're interested in statistics, I would recommend a different application like Autograph. GeoGebra is really good for geometry maths. For example, I've got this thing here where I can move, unfold and fold up a net, and if I drag it around I can see the cube in 3 dimensions. So that's GeoGebra. I don't know much about it, I'm no expert in GeoGebra, but if you wanted geometry resources, just search GeoGebra nets or GeoGebra circle theorems, GeoGebra trigonometry, and there will be something for you there for that. Okay, this is not about GeoGebra today. I just wanted to say that if you wanted to teach geometry, that's how you would do it. Now, when you log into Desmos, this is the screen you will see. I shouldn't say log in because you don't need to log in to use Desmos. You can just use it without logging in. But when you go onto the website, this is what you'll see. And the graphing calculator, the graphing graph is in the center, and over to the left is where you put all your equations. So we're going to have a look at this, and I've typed in y equals sine of x, and I've also typed in a coordinate, and you can see it's labeled on the graph. I can then click the cog icon. The cog icon up here gives me more menus. I click on that, and I can select this button here. This button duplicates the function or the coordinate or whatever else, what other object is in it. So it's a really quick way to streamline your work. Then we've also got these buttons over on the left. So they are next to the function, and that's how you change how the function looks on the screen, or the coordinate. So you click on that, and you can change it to a dotted line or a dashed line. You can change the transparency of the line, the thickness of the line, and you can change the color as well. And so you can make the graph look the way you want to make it as clear as you can to students. Over in the top right corner, we have a few buttons. The spanner icon is useful for changing to radians or degrees, or also changing how the scale of the graph and things like that. But then we've also got the share icon here, and that's to share the graph you're working on with your students or other teachers, or just save it for yourself. So if you click share and then copy, that link will always take you back to exactly what you were just doing. So in 5 years' time, you could click on the same link and it will take you exactly back to the exact same graph in the exact same position as you just were. That's also useful for sharing with your class. So you could copy that link, post it on Google Classrooms or Microsoft Teams, and your students have instant access to the graph you just did. They can manipulate it how they want, and they can interact with it as well. And it's fully interactive from there. So that's really, really powerful. You can also log in to your own account and save all your graphs very easily. If you make an account, you don't have to make an account to use it. At the bottom of the screen, there is this icon here, this keyboard button, and if you click that keyboard button, you have the mathematical keyboard on screen that can help you type things in. I normally just use my computer keyboards because I know the keyboard shortcuts, but you might find that useful if you're typing this yourself. Talking of keyboard shortcuts, we have them here. I've posted a link to this in the description, in the comments as well, so you can see the graphing shortcuts for Desmos. This will save you time and just streamline your lessons. Some important ones are superscript, so that's doing a power, and that's shift 6. Subscript is when you're doing notation involving subscript with small letters. That's shift underscore gets you subscript. You've got the less than or more than signs. If you add an equal sign to that, it makes it less than or equal to. Prime, so if you do this button, it will make it into a derivative or differentiate the function for you. Fraction, you can type in frac, or you can do /, both work. And then square root is sqrt. Pi is really important. I use pi all the time, pi. And then theta, if I'm talking about angles, it's quite nice to type in theta for theta. There are a few more graphing shortcuts on the screen, but I won't go through them all. As I say, I've put a link to this in the description. Now is a good time to talk about some of the resources we made earlier, and you can always find these by going to advancemaths.com/Desmos resources. This is in the comments below, and it's in the description of this video. So Desmos resources is here, and these are the resources that I made for my lessons that I've shared with everybody as well. There's all of them I find really interesting, but I will pick up on a few. And particularly a big topic in the British curriculum for GCSE is transformations on graphs. Now, when I learned transformations on graphs, I did it on pen and paper, and I could only see one picture of a transformation every 5 minutes, because it would take me 5 minutes to answer a question and create a new transformation. But now we can create new transformations of shapes instantly and see how they all relate to each other in a completely new way that was impossible 10 years ago. So here it is. This is the visualization, and what I can do is I can change the scale factor. So this slider down here is the scale factor slider. I can make it bigger, or I can make it smaller, and as you can see, it's updating live on screen instantly. I can even press play here, so I can press the play button and it will animate it automatically for me. So it will animate it automatically like that. Now, let's leave it like that. I can also change the original rectangle. So I can drag the corners of the original rectangle and move them around, and it updates the new rectangle. So I can relate the original rectangle to the new rectangle. I can also move the center of enlargement around like this, and I can put the center of enlargement inside the shape, and I can see how the center of enlargement affects the new rectangle. All of that is live and instant, and it helps students connect ideas about center of enlargement, scale factor, and the original shape to the new transformed shape. We also have simulations for reflections, translations, and also rotations. I'll let you look at those in your own time. I'll show you this one, integration between two curves. So this is a way of showing students what the area between two curves is given by using integration. And you can add or subtract, move A up and down, move B up and down to change the area. You can also change the functions here. So it can be any function you want. Could be sine of x if you wanted it to. And it instantly changes the functions on screen. So we can move back. I'll just undo like that. Now I can also see the other areas involved. So I can see the green area. That's below the higher function, the blue function. I can see the purple region below the other function. And all of these change with A and B. Okay. And it's a way of seeing how the area under each curve subtracts to make the area between the two curves. I'll show you this one as well. This is plotting a quadratics activity. So this is for the students to do themselves. I send them a link to this and they do it on their devices, whether at home or in the class. And they follow these steps over here, step 1, step 2, etc., where they're filling out a table of values like this. Now, the table of values, they put in themselves something like this, and the quadratic will plot itself on the screen live. And these coordinates will pop up from the table of values live on screen. Okay, I'm not sure if I typed in the right numbers there, but it's just a demonstration. So, and then once they've typed in those numbers, they can then press this button here, click on the circle, they're told to click on the circle, and that will hide or show the quadratic. So they can see if their table of values overlaps with the actual quadratic. And then there's a prompt to do a second one there as well. So that's a really nice interactive one that talks the students through the steps as well. Now, the final one I really want to show you is differentiation from first principles. Okay, there's no way I would teach differentiation from first principles without showing them this graph. And this, for any function, doesn't matter what function I choose, you can change the equation if you want to, but it will take any coordinate on this function, you can drag this yourself using your mouse, and it will draw a second line to another coordinate on the graph. So it'll draw a line between those 2 points. And the idea is that we start with the points far apart, and we move the h to be smaller and smaller and smaller, like this, until they're converging on 0, and we see that it converges towards the tangent. And so the second line converges towards the tangent as the distance between these 2 coordinates goes towards 0. Then you've also got the actual tangent is here in the folder on the left. You can click that and it will show you what the actual tangent is. And so it's a way of seeing that the second line converges to the tangent. Okay. And of course there's the equation pasted there as a picture. So I think that's a really powerful demonstration. And the students are welcome to come up to the board and play with these sliders themselves and see how it goes. I must show you as well, before I forget, this one for the standard deviation. So you can see how the standard deviation, the normal distribution curve changes, and you can change the standard deviation, the mean, and you can see how it affects the equation of the point. All of this is done by just typing in the standard deviation, the normal distribution equation there, and Desmos just graphed it automatically. Okay. Those are the results I made earlier, so you are free to use those yourselves if you click on the links that I send you. However, if you're interested in making your own, now we're moving to the demonstration phase of the workshop. The first demonstration I'm going to talk to you about straight line graphs. So we might go to here, and I'll do a new blank graph. Okay, and we're going to start with y equals 2x plus 1, and it immediately graphs it for us. And we can take a moment to talk to our students about the gradient of this graph and where does it cross the y-axis, and have discussions about that. Then we might talk about y equals mx plus c. So I've edited the equation to be y equals mx plus c. It's suggested that I will add sliders for m and c. And so I'm going to do that. I'm going to click for all, or I can just click enter. And now there's a slider for m and c. And I can see what happens when I increase m. And I can see what happens when I decrease m. I can see what happens when m is 0, the line is flat. And then I can decrease m, I can make it negative and it's going down. That's m. Now the c, I can see what happens if I increase c or decrease c. And then it's a nice idea just to label it 0c, and it automatically labels the coordinate that is given by 0c. You can drag that coordinate as well, and it drags the line with it. So that's a way of students realizing that the equation for the y-intercept is, or the coordinate of the y-intercept is 0 cross c up. Okay. Now let's go a bit deeper. Let's talk about two coordinates, x1 and y1. This is the notation we use in the British curriculum. You might use different notation. I've used subscript shift underscore to write the subscript. This is a coordinate, and I can drag this coordinate wherever I want, and it updates the x and y coordinates in the sliders up here. To make it simple, I'm going to go up in steps of 1. So I'm going to click on the slider and make sure it only goes up in steps of 1. And that means that the value of x and the value of y stick to the whole numbers by just going up and down by 1 each time. And that's just going to make my straight lines come out neater later on. I'm going to do a second coordinate, and to do that I'm just going to copy and paste that. I'm going to change it to x2, y2. I'm going to click for more sliders. And I've got two coordinates like this, and I just want it to be like that. And that I want to be step 1, and a step 1 there as well. I'm going to put these in the folder because I don't want to see them all the time, so I'm just going to create a folder and put them all in. And this folder, like that. And this just tucks them in like that, and we'll call that folder coordinates. Okay. To create a folder, you just press plus and then click folder here. Okay, so I've got two coordinates now. Let's talk about the gradient between them. The gradient equation is y2 minus y1 over x2 minus x1. And the gradient is given by 0.5. That's the equation of the gradient. So I can do y equals mx, and we see that it creates a parallel line to these 2 points. I now need to do a c. The c is going to be given by the y coordinate minus m times the x coordinate. That is just what we would call grade 8, 9, 10 maths to find out what the plus c equation is there. And we can put plus c on the end, and it is a perfect line that goes through those 2 points. It doesn't matter where I move these two coordinates, it moves like that. This does break down when the 2 points are on top of each other because the gradient is undefined. It's an infinite gradient, so it's undefined, but it works for anything else. If you wanted to fix that, there is some hocus pocus you can do, but we won't do that today. I can also talk about the midpoint. So I'm going to type in the midpoint equation, x1 plus x2 divided by 2. y1 plus y2 divided by 2, and we're going to label this as the midpoint. And again, this just moves around with my points here. We've got a line between them, we've got a midpoint. Let's now talk about a perpendicular bisector. This is going to be a bit more difficult. I have to remember the equation here. It's minus 1 over m for the gradient, minus 1 over mx, and we've got a perpendicular line. Now we want it to go through the midpoint, so the C2 is going to be the y coordinate of the midpoint minus plus 1 over m times the x coordinate of the midpoint. And we can put a plus C2 on there, and we've created a perpendicular bisector. I realise that's a quite a weird equation there. That is just coming from your straight line graphs equations, and if you sit down with a whiteboard you can work that out yourself, but it takes a bit of time. I did not do that in my head, so that's just something I've memorised from earlier. But it gives you an idea of how you could create a perpendicular bisector, a line between 2 points, and a midpoint. And so you can investigate straight lines and visualise straight lines very easily for any 2 points. Okay, that's straight line graphs. Now, let's do another one. We are now looking at function transformations. So, I made something earlier. I made this function earlier. And I chose this function, this piecewise function, because I wanted it to be a weird function that the students can really see how it flips, stretches, etc. And they can see how it works. You could just use a quadratic. You could replace all of this gibberish up here with a quadratic if you wanted to. But I feel like when you're doing function transformations, sometimes the confusion does happen with quadratics. That equation there is how you write a piecewise function. Bit complicated, but you're welcome to just copy it from my website. I have this uploaded on my website. You can edit it how you want, of course. So if you just wanted to make this sine of x, you're absolutely welcome to do that, and the rest of the visualization works the same. So just going back, now we can edit the g of x function minus f of x plus 4, and we can predict what the new function looks like. Well, the minus f of x will flip it, and then the plus 4 will move it up by 4. So I think this will be a flipped function, and I moved up by 4. The coordinate of the vertex, I think, will be the x coordinate will stay as 5, but the y coordinate was 3. You flipped it to be minus 3, and you added 4. I think it's going to be 1. So we're going to label that the new vertex, and we're predicting that's going to be 1. You can have a class discussion about this and talk through this with the class, talk through the steps there with it as well. We can now show the function and see if it matches up. And we can see that the function does indeed do this. We can change any of the parameters. We can stretch the function. We can add things like this. We can do that. And we can manipulate the g of x however we want and instantly see the function transformation straight away. Okay? This is one of the resources that I have on my website, but you're welcome to make something similar using the ideas that I just showed you. Next one, we're going to do a quadratic graph. Okay, so quadratics are really, really fun. In IB curriculum that we teach, there's a lot of chapters just about quadratics. Well, there's a big chapter about quadratics, and students really have to be familiar with the different points of the quadratic, the roots, the vertex, the y-intercept, etc. And to start by just typing y equals ax squared plus bx plus c, the generic quadratic. And we're going to start by doing make sure the sliders are just going up by 1 each time, just because it's nicer, it's easier to control. And at this point, I would talk about the A, B, and C, but specifically A, I make the A steeper, and I make the A 1, I make the A 0 to make it a straight line, and I'll make it minus, I'll make it negative, and just have a discussion with the students about how the A is probably the most important parameter that affects the shape of the quadratic the most. I can now start talking about the y-intercept. I'm just going to tidy this up, put this into folders. So let's just put this into a folder like this. It'll get very messy otherwise. So quadratic. I'm going to hide it. Okay. Now the y-intercept is 0 across C up. And we can label that and we can call it the y-intercept. So I've just labelled that the y-intercept, and over here it's showing where the y-intercept of the quadratic is, and I can drag that wherever I want. The roots. The first root is given by the quadratic equation, minus b minus the square root of b squared minus 4ac over 2a. And so the first root is x1 is 1. And so I can type in there and label the roots. There, root 1. I'm going to copy and paste this and make a second root like this. I'm going to change it to the positive. I'm going to change this to x2. I'm going to make this x2 as well and root 2 there. And so now, for my quadratic, I have the 2 roots and the y-intercept labelled like that. Next thing I will talk about is the equation of the vertex. So the vertex is given by minus the line of symmetry to start with. Line of symmetry is minus b over 2a. I can make that dotted to make it clear that it's a line of symmetry. That's the equation of line of symmetry. Just comes from completing the square. And the vertex, For this, I'm just going to make it, instead of y equals, f of x equals, and that just makes it life a little bit easier. The vertex is minus b over 2a, that's the x coordinate, and the y coordinate is f of minus b over 2a. Okay. Again, if you sit down with the quadratic equation and do a little bit of algebra, this stuff just pops out straight away from that. Okay, so now I've got a 2 roots, line of symmetry, y-intercept, and the vertex labelled, and we're going to call it the vertex. And this always changes depending on what your A's, B's, and C's are. And it will work, of course, when A is negative as well. Like that. Now, I've given you that so far. Now, this is a great opportunity to talk about conditional formatting. And so changing the colour of things depending on what's shown on screen. And so we're going to talk about the discriminant. B squared minus 4ac. So here the discriminant is positive because it's got 2 roots. We could have the discriminant as negative, having no roots, or it could be 0. If the discriminant is positive, I wanted to say d is more than 0, 2 roots. So we're going to choose a coordinate just over here where we can see everything. And let's choose a coordinate 2, 2. And we're only going to show that coordinate if d is more than 0. And so I'm using curly brackets here to tell the Desmos when to show it and when not to show it. We're going to label this as d is more than 0 to 2 roots. We're going to make the text big by changing the scale here. D is more than 0 to 2 roots. And we're going to make it green because I think green represents 2 roots quite well. Like that. I'm going to copy and paste that twice. I'm going to make one version where it's equal to 0. Like that. 1 root. I'm going to make one where it's less than 0, where there's 0 roots, and it says there. I'm going to make this one orange, so students can see the colour coding as well. I'm going to make this one red, because I feel like red represents no roots. Now I can change the value of the quadratic. So we're going to drag up the C, and you see it's going from green to orange for 1 root when it's got 1 repeated root, and then when it goes above 0, it changes again to be 0. 0 roots. So it turns into red. And that's an introduction to kind of conditional formatting, how that can be useful for connecting ideas on screen, color coding ideas. Okay, I do have a more complicated discriminant visualization here that I did, and this one changes the color of the curve as well. So you've got the curve here. Let's move the C up. So you see the curve is changing from red to green there as it moves up and back down. Okay, so you might want to play with it more and see if you can create it, make it in your own style. Okay, we're doing good so far. Let's now look at some things about differentiation, tangents, and normals. This is our last demonstration. Just bear with me. I promise it'll be over soon. So we'll do the new blank graph, and we'll type in some function f of x, and I like x squared, x squared. The way I'm going to set this up is I can change f of x later on, and it still works. I'm going to choose a coordinate, x1 and f of x1 to make it fit the curve like that. And now this is just a coordinate that hugs the curve. So I can drag it up and down, and it will stick to the curve. Now, to find the derivative, I type in f dash of x, and it evaluates the gradient at that point, the derivative at that point. So if I do f dash of x1, and I can change the f dash of x1, it tells me the gradient at that point just by typing that in. Y equals f dash of f dash of x underscore 1 tells me, and then I multiply by x, there we go, and it gives me some parallel line to the gradient at that point. I now need to add on some maths to make it the same y-intercept as the tangent, and it's given by this equation here, which I spent a bit too much time working out earlier. So I'm not expecting you guys to figure this out on the spot, of course. But it's that equation there. It's not quite worked. Why is that not worked? F dash of x1. F of x, that should be f of x there. There we go. And now it's a perfect tangent. Oh. Okay, and I can drag it, and that's just a really nice way to show your students what a tangent looks like. This is a good time to change it to sine of x, so we can make it sine of x, and we can see what a tangent of sine of x looks like. I'm going to label that, so I'm going to label it the tangent. I'm going to do it, label it as x1 plus 1, just move it over slightly, and f of x1 plus 2, no, x1 plus 1, no, what I'm doing is this is it, that's what I want to do, g of x, there we go. I'll change that to g, and g of x1 plus 1, and that just gives me a point later on the tangent to label a tangent. Okay. So all I've done there is just moved the coordinate over slightly and labelled the tangent at that point. So it's not on top of the point, it's just clearly following the tangent as we go. Okay, final thing I'm going to do today is try and do a normal to the curve. And for this, I just need to make it minus 1 over. So I'll make the gradient minus 1 over. And there we go. And I'm just copy and pasting here to save myself time. And there we go. Perfect. A perpendicular bisector. Let's do it in a different colour. And that's in green. And I can make it dashed if I want to make it a bit more, look a bit more like a normal. And I'm just going to also copy and paste the label for the tangent and make that h of x, like that. And now we've got a fully working tangent and normal there for you. And this is just to show students what a tangent and normal looks like. It's just so they can get the idea around what a tangent and normal really means in the real world. Okay? So, those are the 4 demonstrations I wanted to show you today. Thank you for listening. I really appreciate your time. Before we go, I'll just tell you a bit more about what we do at Advanced Maths and how it might be able to help your students. So we have revision guides for Year 6 to Year 11 British curriculum, and then revision guides for IB, and quite a few resources for A-level as well. And the idea here is that these revision guides are complete with revision videos, practice questions, and extension for all topics from Year 6 all the way up to Year 11. And it should be able to keep students fairly busy, so they can always find things to revise at home. And you go to here, Year 8 revision guide, and we've got all these here. All these videos were made by Advanced Maths, and all the resources are from various other websites around our favourite resources from external websites, and some of our own as well. We also have a section for teachers here, so if you go to Advanced Advice for Teachers, there's some resources for there you might find useful. If you are an IB teacher, you've also got the IB Diploma Revision Guide here, and that's got, for analysis and approaches, there's another one for A and I, and it's the full revision guide for the IB course there with resources. Okay, so thank you for watching. We really appreciate your time. if you could drop us a like and subscribe, that really supports Addvance and helps us in the future. If you have any questions, I'm just going to take a moment to check the comments now. If you just bear with me a moment, but the workshop has finished. I'm just going to have a look at the comments and see if there's any questions I would need to answer. If you've got no further questions, we can wrap it up there. But if you give me a moment, I'm just going to check the comments and I'll be back in 1 minute. Thank you. Sorry, I was on mute. Thank you for joining, everyone. Good to see some people commenting below. If you have any questions for me, please do comment below. And let me know if you have any questions. You're also welcome to email me at any time. The recording will be available on YouTube shortly after this. So you're welcome to share it with your friends or your department if they will find it useful. Thank you so much for joining. Have a lovely evening and good night.